Hey guys, welcome back. In this lesson, we're going to learn about an interesting file format named RCFile. Before we look at what is RCFile and its structure and how it is used, let's first understand the need for a file format like RCFile. We all are very familiar with our stocks dataset. The stocks dataset is a simple text file with row-by-row information. Each row in this file is a record which has the exchange name, symbol, date, high and low for the day, volume, closing price, etc. So when a file like this is stored on disk, it is for the most part stored in disk continuously. There could be some fragmentation, but let's assume for the most part it is stored continuously. We have used this dataset with Hive, and let's say we have a Hive table named stocks. And the dataset behind the table is our stocks dataset. So when we write a query, select star from stocks, we have to start reading from start of the file and read the data as it laid out on the disk and display the results. Since the data is stored continuously, our read operation is faster and efficient. Since we are storing our dataset row by row on the disk, we can call this a Rowstore. A typical Rowstore will have much more than just data, but for simplicity, we will refer our row by row dataset as Rowstore. In a Rowstore, selecting all records or even selecting a set of records is pretty efficient. Now, let me ask you a question. Do you think a Rowstore is efficient to select one or few columns from a table? Give it some thought. Let's look at how this simple query to select volume from the stocks table would work behind the scenes. To select just the volume in a Rowstore like this, we have to travel the entire row through all the columns, skip the columns we are not interested in, and just read the volume column. Once the volume for row 1 is selected, we have to do the same thing for row 2 and row 3 and so on. The read operation to select just one column from a row is not very efficient. Our volume column is almost at the very end of the row, which means to reach the volume column, we have to traverse all columns which we are not interested in and skip those columns to reach volume. So the Rowstore, which is efficient in reading all the columns in a row, is not efficient when it comes to selecting one or few columns. If you think about it, most of the data analysis operation involve working with few columns from a table. An example data analysis query would be finding average volume by stock symbol. So a Rowstore is not an ideal structure for data analytics. So what is the solution? Why don't we group all the data from the column together? Something like this. Here you can see that the value for the exchange column is stored together. The value for the symbol column is stored together, meaning on the disk they will be stored in contiguous location. Volume is also stored together. So when we run a query to select just volume, all we have to do is start from here and start reading. There is no need to read unnecessary columns and skip them. So if we would like to calculate average volume from this representation, we can read all the volumes in one stretch and calculate the average. This way of storing the column values together is referred to as Columnstore. As you can see, Columnstore is very efficient in performing operations on a column or a set of columns. But what if you would like to select all columns from the third record, for instance? We have to read through the values in the first column, fetch the third value, ignoring value 1 and 2 because they belong to row 1 and 2. Next, we move on to the values for the second column, fetch the third value, ignoring value 1 and 2, so on and so forth. While a Rowstore is not efficient in dealing with column-specific queries, a Columnstore, on the other hand, is not very good in dealing with entire rows as the data for a given row is scattered in the disk. There is one more problem with Columnstore when it comes to big datasets. Let's say our stock dataset is 1 terabyte in size, and we decide to store the data in a Columnstore fashion. Since the dataset is 1 terabyte, the dataset will be divided into blocks and will be stored in multiple nodes. Since the dataset is huge, all the column data to reconstruct a single row may not be on the same block and on the same node. Think about this. In a Columnstore, we are storing all the values for a single column together. In a big data set, one block of data may not have any information about another column. Data points for column 1 could be on block 1, and data points for column 3 could be in block 8 on a totally different node. And data points for column 6 could be on block 17 on a totally different node. So to construct a record, we have to read from block 1 to read data for column 1, and we have to read from block 8 and 17 to get the data for column 3 and column 6 respectively. And we are in a similar situation to fetch other columns as well. To make things worse, we have to go to different nodes to get information from the various blocks. It is not very efficient. So files stored in a column store fashion, while efficient in dealing with specific set of columns, it is not great in dealing with retrieving entire rows. So in summary, Rowstore is better when selecting entire rows and not great if we have to select and work with only certain columns, because then we have to read and skip columns which we don't care about. On the other hand, with Columnstore, it is very efficient to work with columns because all the column values are grouped together. But with big data sets, if we would like to get all columns from a row, it would be very inefficient because the data is spread across multiple nodes. So what is the solution? How about we take the benefits of Rowstore and benefits of Columnstore and combine them together, while at the same time avoid the inefficiencies from Rowstore and Columnstore? And that is exactly what RCFile did. RCFile is created as a result of a joint effort between Facebook, Ohio State University, and Chinese Academy of Sciences. RCFile simply combined the benefits of both Rowstore and Columnstore, and at the same time overcame the efficiencies of both row and column store. And here is how they did it. Let's say we would like to convert our stocks dataset, which is a standard text file, into an RC file. In an RC file, records are first partitioned horizontally and then vertically. What that means? You would first divide the file horizontally, or in other words, you would group rows together. In RC file terminology, they are called row groups. Inside each row group, the column values of each column will be grouped together, just like a column store. In the illustration, you can see our original dataset on the left is divided horizontally into two row groups. Inside each row group, the column values for each column is grouped together. So first, the data is horizontally partitioned into row groups. Next, inside each row group, it is vertically partitioned. That is, the column values for each column is grouped together. You can easily see now we have the benefit of both a row store and a column store. If we like to select a set of columns or do aggregation on a column, it is easy to do because the values from the column are grouped together. Take, for example, if we would like to calculate average volume for this dataset. All we have to do is go to row group 1, locate where the volume column is stored, and read all the values for the volume column. Next, we move on to row group 2 and do the same. Once we have read all the values for the volume column, we can easily do an average. Next, let's say if you would like to select all columns from the third row. It is easy to do that too. Since the data set is first divided into two row groups, all columns for a given row is inside a single row group. For example, if we would like to get all columns for the third row, we will find all the information we need in row group 1. The row groups are 4 MB in size by default. So all the columns for a given row will most likely be in a single block in one node. There are other benefits to RCFile, which makes the RCFile even more efficient. With the RCFile, you can apply compression to each column separately. And since all the values in a column are of the same type, compression is very effective. All the columns in RCFile are compressed using gzip by default. Next benefit is an interesting one. It is called lazy decompression. While reading an RC file, a column is not decompressed until it is absolutely needed. Consider this query. Select star from stocks where symbol equals RSC. In a row group, each column is compressed, so to read all the column values for symbol RSC, we would have to decompress all columns in each row group and select only the rows with symbol RSC. Can you think of any ways to make this process even more efficient? Okay, I'll ask another question. do you have to decompress all columns in each row group to select only the rows with symbol RSC? Give it some thought. Did you answer yes? Wrong. This is what RCFile does. It decompresses only the symbol column in each of the row group and examine the values in the symbol column for symbol RSC. If it finds RSC, then it moves on to decompress the other columns. If it doesn't find symbol RSC in a row group, there is no point in decompressing the other columns in that particular row group, because we're only interested in seeing the rows for symbol RSC. In such cases, RCFile will skip the entire row group. So in our illustration, RCFile first decompresses the symbol column in row group 1. It does not find the symbol RSC in row group 1, so it will not decompress the rest of the columns in row group 1, because there are no records to select in row group 1 for symbol RSC. RCFile will then move on to row group 2. Here again, it decompresses the symbol column and it will find symbol RSC. So it will decompress the rest of the columns to fetch all records for symbol RSC. Pretty interesting, right? And this is referred to as lazy decompression. And this feature of RCFile alone brings massive efficiency for queries with predicates, or in other words, queries with filter condition. Let's now look at the structure of the RCFile in depth. As mentioned, RCFile is divided into row groups. The row groups are by default 4 MB in size. Why 4 MB? In the big data world, 4 MB of anything is small, right? Creators of RCFile spent a lot of time in deciding the row group size and settled on 4 MB. When you have smaller row group size, lazy compression can benefit from that. Let's go back to our previous illustration. Imagine row group size is 40 MB instead of 4 MB. This means each row group will now have about 10 times the number of records. And you run the same query to filter records for symbol RSC. Now imagine we only have one record with symbol RSC within the 40 MB worth of data. With lazy decompression, we will decompress the symbol column on our row group, which is now 40 MB. We'll hit a match and we'll now go ahead and decompress the other columns. This means we are decompressing the entire row group, which is 40 MB in size, for just one row. Now let's compare this with the 4 MB row group size. And the same scenario. We have 40 MB of data, but the data is divided into 4 MB row groups, so 10 row groups in total. And only one record matches the symbol RSC. Now we will decompress the symbol column in each row group. And when we hit a match for symbol RSC, we will only decompress the specific row group. Since we have one record with symbol RSC, we'll hit the match on only one row group. And this means we are only decompressing the remaining columns on a much smaller 4 MB row group this time, instead of decompressing the entire 40 MB worth of data for one row in case of the row group with 40 MB in size. And for this reason, the creators of RCFile settled on a row group size of 4 MB. A row group is made up of 3 sections. First is the sync marker. Sync marker acts as a divider between row groups. If you recollect, most compressed files are not splittable by default, and sequence files solve that issue by introducing sync markers. That is exactly the purpose of sync marker here as well. Sync markers in RCFile act as a divider between 2 row groups, and it also helps the reader move from one row group to another easily, thereby allowing the file to be splittable. The second section in the row group is a metadata header for the row group. This header stores some basic information about the row group, like the number of rows in the row group, size of each column, etc. The third and final section of the row group is the actual data, or the column store, where all the column values for the rows in the row group are stored, column by column. And all values are stored in binary format, and hence it is not human readable. That is it. An important note here. Do not confuse the 4 MB row group size with the block size in HDFS. RCFile will still be divided into blocks with the block size defined in HDFS. So on a Hadoop cluster with 128 MB block size, RCFile will be still stored as 128 MB blocks. Inside each block, RCFile will then group the data into 4 MB row groups. So a RCFile will be divided into 128 MB blocks, and inside each block, we will have many 4 MB row groups. RCFile is an intelligent format, don't you think? It is truly a hybrid between a row and a column store. So to summarize, in this lesson, we saw the need for a file format like RCFile and its benefits. We also saw the design and structure of RCFile in detail. In the next lesson, we are going to look at how to use RCFile with Hive and Pig. See you in the next lesson.